are piezoelectric devices inherently so efficient in comparison to their electromagnetic counterparts? As you know, there's many types of actuators. There's electromagnetic actuators, like linear actuators, like stepper motors, like linear, and also there's a piezoelectric type of motors as well, and also piezoelectric devices, speakers and things along that nature. So most of the time, whenever we have a comparison between an electromagnetic device and a piezo device, there's one inherent part in a piezo device which really makes it shine in terms of efficiency, especially when you get to smaller sizes. Now, for larger sizes, electromagnetic devices, they actually are better. They're better than piezo, even though piezo seems like so kind of advanced and it's the future. They are better in many, many ways for many applications when you're talking about power. Hence, you're not going to find a piezo motor powering an electric car, for example. Why did that happen? Aren't piezo efficient? Don't we want efficiency? Yeah, there's a reason. But basically, when you want small size, there's a big difference that occurs. Electromagnetic devices are, well, magnetic fields, which requires current. There's a coil of some sort, and basically as you make that the area smaller, basically using smaller and smaller wires as you're getting to a smaller device, your resistance goes through the roof. There's no way around that. It's physically what has to be. Physically what has to be there. Equations which you can't change. You're going to have that resistance. However, piezoelectric device requires an electrode, which is then used to transfer voltage. Now, piezo devices also do draw current, but they aren't but their current drawing capabilities or the necessity is not really coil based, because the coil is not, there's not like so many turns of wire driving up the resistance of the basic device, which now is very size dependent. Piezo's electric devices do scale well in terms of efficiency with size, and hence it allows you to create an effective device along different scales, especially the small scale. So because the piezo devices don't have a coil, you just simply need to attach a wire however long you need it for practical reasons, not for physical generation of the basic fundamental physics of the device. You just need to deliver that voltage, and it does transfer current, but nowhere near the amount that's required for a electromagnetic device. And as well as you don't have all that coil, now whatever current is now being drawn, it's not being drawn through a high resistance coil in order to deliver that magnetic field. So that's one of the reasons why piezo devices are very efficient, and they're preferred for smaller devices because they don't require coils, and which actually makes them a lot more easier to manufacture reliably and consistently. All right, so you've been watching the Piezo Sock Show, episode number 68. My name is Hussein Shakani. I am a consultant for ultrasonic transducer development, especially in the area of simulation. So if you need support in that area, check out the links in this video for a link to my website, and I'll be happy to get in contact with you and help you there for those companies developing ultrasonic transducers and they need a bit of help. I'm there for you. All right, take care and see you in the next video. And also, I have a webinar coming up. So if you do go to my website, Ultrasonic Advisors, you'll find information for that webinar. So I look forward to seeing you there, and as well as on YouTube again, and subscribe to this channel in order to get updates as I post them. All right, thank you.